As we move on, we're going to go ahead and do the goddess of 5/7 and 5/8. We're going to put to practice what we've been going over. Now, Pascal's triangle, it is very important that you've kind of taken all this triangle down. And in fact, I'm going to go and I'm going to take this triangle down even one more. I'm going to go down to row 8. Okay, so before we do the next goddess, because I know in the next goddess we need to go down to row 8, let's please go ahead and do so. Okay, so I'm going to take my ones over, and I'm going to start joining stuff up in the middle. You ready? 1 and 7 makes 8. 7 and 21 makes 28. 21 and 35 makes 56. 35 and 35 makes 70. 35 and 21, we see our repeats. 56 and 21 and 7 makes 28. And one more, 7 and 1 makes 8. Almost forgot that little one. So this is row 8. I think in your homework tonight you might need to go even into like row 9 or something, but you get the idea. So let's go ahead and got it. Number 1. What's the expression? Now remember, this would be really, really painful to write that out 8 times. And I should make a note so you don't make the mistake that a lot of people have. The answer is not, big mistake, A to the 8th, B to the 8th. A lot of people make a huge mistake with that, so that's definitely not right. Now instead of having to write this thing out 8 times and come up with a super obnoxious problem, we're going to use Pascal's triangle and the rule for the 8th row. So row 8, because we have a power of 8. So I'm going to flip back over and I see it's 1, 8, 28. Just doing the one I just did. 1, 8, 28. 56 and 70. These are again just the things we just did. And then I'm pretty sure it starts going back. Then 56, 28 again. Backwards. And one more time, 28, and I think it's 8 and 1. I think 8 and 1. There it is. Now, the first item is A, or the first term. So I put A to the 8th here, always to the highest power. And then A to the 7, A to the 6th, A to the 5th, A to the 4th, A to the 3rd, A to the 2nd, and then A to the 1st. And then essentially this one would be A to the 0, so we just don't write it. Now we go backwards with the second item, B. So B to the highest degree, 8, B to the 7, B to the 6th, B to the 5th, getting real small here, B to the 4th, B to the 3rd, B squared, and B. And then all of these are addition because everything started as addition. We really do like those problems that start as addition. And we're all done. That is what the polynomial would be if you wrote it 8 times and FOILed all of those together. Let's move on to some more bigger, more difficult problems. Important concept to note here is that 2x replaces A and -3 replaces B. This is to the 4th power, so I need to use the 4th row. Okay, so if you want to take a look at your 4th row, it's down here. I got to use these numbers, 1, 4, 6, 4, 1. Let's spread them out. 1, 4, 6, 4, 1. Get them spread out. Now 2x I'm going to put in parentheses because it is a monomial, but it has a monomial with a coefficient, and that is going to be to the highest degree of 4. And then parenthesis 2x to the 3rd, so I'm going down. Then parenthesis 2x squared, and then parenthesis 2x to the 1st. And then no more 2x's. Now the -3, be very careful, you need to include the negative. So -3 4 times, -3 to the 3rd. Again, we're just working backwards, -3 squared, and -3 to the 1st. A note worth mentioning is look at the exponents here. These exponents always add to your highest exponent, like 1 and 3 makes 4, 2 and 2 makes 4, 3 and 1 makes 4, and then these ones are 4. Something maybe worthwhile to mention. Now, let's go ahead and do this. 2 to the 4th power is 16 times 1. So this becomes 16x to the 4th. Now we got to be really careful here. 2 to the 3rd is 8. 3 to the negative 1 is negative 3. So essentially I have 4 times 8 times negative 3, negative 96x cubed. That's a negative sign there with that 3. Okay, keep going. So this one's going to be 6 times 2 squared is 4. Negative 3 squared is 9. And 6 times 4 times 9. And this is going to be, since this is a positive 9 now because it was negative 3 squared, we're going to have a plus 216x squared. Okay, I'm just going to double check my math real fast. 6 times 4 times 9. Okay, 216. Next, this will be a 4 times a 2 because 2 to the 1st. Now negative 3 to the 3rd is negative, negative, negative. So times negative 27. So all of that together, 4 times 2 times negative 27 is negative 216. X has the power of 1. And then the last one is 1 times, well, negative 3 to the 4th is a positive 81. So I'm just going to drop down a plus 81, and there's no more x's. So this is the 1, 2, 3, 4 polynomial of 5 terms you would get if you were to FOIL that thing 4 different times. And that's all 5-7 was about. It was in Pascal's triangle. I'll tell you right now, Miss Miles needs you to know this when you get more advanced. I think it's in Calc she says that she uses it. And so it's going to be very beneficial for you to kind of get used to it before you go on. Let's do the got it number 1 from 5-8. What polynomial function has a graph that passes through these 4 points? So what I'm going to do first, I'm going to notice that they have given me 4 points. If you were to plot these points, they would kind of be all over the place. They wouldn't make a lot of sense to us. So what we're going to do is we're going to put them on your calculator. Okay? Oh, and what does 4 points? We should also make mention, I'm sorry, that if you did plot them, they would pass the vertical line test. In other words, like one wouldn't be on top of the other, okay? And they don't make a straight line, so we can say that they are nonlinear if you were to plot them. And you can take the time to plot them, or you can just kind of realize they're really out there. All right? So what we're going to do is we're going to grab our calculator. You guys should be used to this. You hit Stat, you go to Edit, and you clear out your lists that you have. All right, and clear, enter. Now we're going to put in the x values that we have. So that would be negative 2. The next x is 0. The next x is 2. And the next x is way over here, 3. So I have my x's in. Now I'm going to go to my y's. Negative 2 goes with 1. 0 goes with 5. 2 goes with 9. And 3 goes with 36. Next step is we're going to hit Stat, go over to Calc. Now we really have to pick which one we think it's going to be best with. Well, since they gave us 4 points, we are going to use the cubic one. We like to back off 1. We're going to try the cubic and see how good of a fit this is. So I'm going to go down to number 6. Oh, I did it wrong, sorry. Stat, over to Calc, number 6. Now, if you have a fancier calculator, you want to make sure that it says L1 and L2. Mine automatically registers L1 and L2, so I'm just going to hit Enter. And this is the equation that we get. Look at r squared. Can you see how r squared is 1 when we do it on our calculator? That means it is a perfect cubic graph. You might want to write that down. R squared equaled 1, so it's a perfect cubic graph. That means we did a really good job in the one that we picked. So now what we're going to do is make our equation. Y equals, so I put the a in front of x cubed. So 1.67 when you round, x to the 3rd power. And now b is going to go in front of x squared. So that's scientific notation, everyone. So plus 1.3 times 10 to the negative 12 x squared. That is, again, scientific notation. That's a very itty-bitty number. C is the number that goes in front of x. So I'm going to move my calculator over here. Plus, or minus, since it's a negative, excuse me, minus 4.67x. And then my constant, the letter D, is a 5. And that is the equation that would represent those points. Now, if you were to put that equation into y equals here, you would see that that equation, like when I hit graph, I know I don't have anything on there, but if you were to hit graph, this equation would go through these 4 points up here perfectly. Okay? Maybe I'll do another video so you can see what that looks like. But from now, let's go ahead and move on. I've already done these got it's for you and got it 3. So the last thing we need to do is got it number 4. Okay, so I probably need to go back up and see what was going on in number 4. It says use linear regression to find the linear model for this cheese consumption. Okay, so we have to kind of rewind and take our brains back to this problem. We were talking about what year it is and how many pounds of cheese people have consumed. Holy cow. We can see, right, that it was going up super fast. We did notice that a cubic graph seems to fit them extremely well. Look at those dots and how it goes through with it. Now what they want us to do is to take these points and they want us to make a linear or a straight line of them. All right, so what we're going to have to do is go to, kind of crazy, I'm going to have to go to our, there we go. Have to go back to our calculator. We have to go to stat. Now what I'm going to point out here is that they made x equals 0 in 1990. So again, when we go to our stat button and we type in our numbers, we're going to have to make sure that we follow alike so we can actually see the difference here. Okay? So I'm going to have to go back and re-plug this stuff in. Alright. So if they made 1900 0, that means that 1910 is 10. 1940 is 40, 1970 is 70, 1975 is 75, 1995 is 95, 2001 is 101. So those are my x values. And then they didn't change these at all. These are the pounds of cheese that people have, wow, eaten. So there we go. You get your pounds of cheese on there. Now I'm going to go back here so we can talk about what they call the linear model, so the straight line model. And let's go ahead and check it out. So we're going to hit stat. We'll go over, and they want us to try the linear one, number 4. And so here we go. There is our linear equation. Let's write it down. Y equals A, which is your slope, 0.2699. Let's just round it to 2699. X minus your y-intercept, 3.919. Let's make it 7. So that is your linear model. They want us to graph it, which we will do. But before we graph it, let's notice that R and R squared are extremely low. That means it's not a very good fit. We should kind of recognize that. Let's write R and R squared are pretty bad. Which means it's really not a great model, but they want us to just go ahead and talk about what it would be even if we did use this linear model. Instead of the one that we used up here, we used the cubic model. Okay, part B. Use this model that you found to estimate the consumption in 1980. Well, 1980, we'd have to plug in 80. Okay? Well, then they want us to do 2000. So if they want us to do 2000, that means we need to plug in 100. And they want us to do 2012, which means we need to plug in 112. So we're going to see which one makes sense and what our estimate would be based on these items. Grab a calculator, hit clear, and just use your model. 0.2699 times 80 minus 3.9197. So 17.7 pounds of cheese. Alright, and that would be in 1980. And now we'll plug in 100. So 0.2699 times 100 minus 3.9197. 23.1 pounds of cheese. It's crazy. In the year 2000. And 2012, we're going to plug in 112. And I get 26.3 pounds of cheese. Okay? So if we keep reading the question, it says, which one do you have the most confidence in? Well, what you want to do is you want to kind of take a look at your graph, your chart here. Okay? Like this is the chart that's on the back page. So like in 1980, that's going to be around year 75. That's not too bad. So yeah, in 75 we can see it was like 10 pounds, and in our graph we got, or in our equation we got 17.7, so that's not too bad. Let's see, the next one was year 2000. Well, you can see in 2001 we got 30, so this one is really starting to get off, isn't it? Very off. And then look at this, past there, in 2000 in our actual chart, it actually says that in 2000 there was 30 pounds, or 2001 there were 30 pounds. So if they're asking about 2012, we can absolutely say that this is way too low. Okay? So that one's way too low. That's the one that we're going to have the least confidence with. This one up here was the closest one, 17.7, so that's one we can be most confident. So really all this problem is trying to explain to you is that sometimes one equation, like a cubic equation, might be a much better estimate than a linear equation. The last thing I'm going to do is show you on a calculator the difference between the two of them, okay? You don't have to watch this portion of the video, but I would like you to see. So bear with me. I'm going to first of all put these points on your calculator. Again, you don't have to watch this part of the video, but it will be beneficial if you want to see the difference between the two graphs. To check out my window, I need my window to match my chart. Okay? So here's what I'm trying to get to. I'm going to have to use these numbers. I'm going to start at year 0, which would be 1900. I'm going to go up to year, let's do 150. So that would be like 2015. I'll skip by 20s, that's not a big deal. Now my Y minimum, I'm going to do 0 pounds of cheese, and then I'm going to go up to, since this highest one was 30, I'm going to go up to like 60. Take a look at the plots. You can kind of see they're not in a straight line, right? And if I want to make it better, I guess maybe I wouldn't make it as tall or as long, but these dots here are the picture of this chart here. Now what I'm going to do is go to y equals and plug in both equations that I had. So since this is to the negative 5th power, I'm going to have to put that in my calculator. So 9.24 times 10 to the negative 5th power, and that is with x cubed. And then you have to do minus b, so minus 0.0096 x squared, and then c plus 0.3106 x, and then d plus 1.802. Now when I hit graph, you'll notice that this line goes through those points extremely well. That's why r squared was so close to 1. It really fits our dots well, and this is a cubic graph. Now what I'm going to do is get the other equation that we had on the back of the page, the linear equation, and I want to show you how this one is really a poor representation of our dots. So we'll go down to y2, 0.2699x minus 3.9197, and now take a look at that, and you can see that the line really does not go through those dots very well. It balances the dots well, but since it really isn't a very good fit, that's why our numbers that we got over here, that's why these numbers were so off And these numbers up here were so good. Okay, so I hope that kind of clears up the whole difference about why would one work and one doesn't. And that's it.